Hello guys, welcome to Code. And today you're with me, Kulio Kininda, software engineer with a little over 7 years experience. And today I'll be taking you through the ultimate Spring developer series from beginner all the way to advanced on how you can develop enterprise grade, world class Spring web applications. So without wasting any of your time, let's get cracking. The agenda for this series includes Spring Framework, Spring Core, Spring Boot, Spring Cloud, Spring MVC, Spring Data JPA, Spring Security, as well as Spring Integration. By the end of the series, you will understand how to use all of these modules to create an enterprise grade web based application, and you'll be able to deploy that into an environment such as your AWS EC2. So let's get to it. For the prerequisites in this particular series, you're looking at Java fundamentals, object-oriented programming principles, your inheritance, your polymorphism, abstraction, and things like that, and also basic web application understanding on how web applications behave, or if you've used like a HTML, CSS, JavaScript, and things like that. Basic database understanding. This will be querying a database, creating a table, adding columns, inserting data into the database, retrieving data from a select, and finally some version control understanding like your Git or similar version control. Now that we have our CRUD operations in RESTful APIs, and we have essentially seen how to create our APIs and expose them and test via Postman, we will now look at the Spring Data JPA module and see how we can have business logic that interacts with a database. We can store our student data, update it, delete, and also retrieve that data via all these operations. So let's jump quickly into our Spring Initializer. You will see here we're still using the same project. All the configs are still the same, and the dependencies are still intact. We are going to add the Spring Data JPA module, and this is to persist data in SQL stores with Java Persistence API using Spring Data and Hibernate, which is what we are going to be using. Also, now if you're more interested in further details, let's just say Spring Data JPA, and we are going to, just for references, you can also go to Spring IO where they give a full breakdown of what Spring Data JPA is, but essentially this is the Spring implementation of the Java API persistence API that handles communication between your application and the database, and it also uses it actually implements a data access layer that separates responsibilities between your Java application and database. The responsibilities of our service should be the Java work, and database should handle data related transactions and processing. So we shouldn't confuse the two, and this particular module helps us to separate the responsibilities between application and the database. Let's get into what that does. So now that we've added Spring Data JPA, let's add another one, which is the Postgres driver, as we are going to be integrating to PostgreSQL. So now we have that. And just to show you how the database looks like, I am using a Docker Postgres image, and you'll see my container is zip code PG. And just to show you how that database looks like, I'm going to jump into dbeaver. You will see in dbeaver I have the Postgres DB, and my database is tutorials database. And in the tables, I have the student table just like that. And I do have how the table looks like. There's two records, John and Jane. And if I look at the properties of this particular table, I'll see that the columns is ID, first name, email, mobile, and created date. So all of the columns that we have in our student DTO over here are available in this particular table. So now we need to add these particular dependencies into our project so that we are able to talk to our database essentially. So with all of that being said, and these being added in the initializer, I need to add them in the POM file because the project is already in IntelliJ. So what I'm going to do instead, I'm just going to say Spring Data JPA dependency Maven, right? And I'm just going to take the org data JPA dependency. I'm going to take this one, and I'm going to come back to my, we need the Postgres one, and the reason why I'm using the PostgreSQL driver Maven, the reason why I'm using Maven is just to showcase where all of these dependencies are coming from. So you should be able to, if the dependency, you can't find the dependency in the initializer over here. So there are dependencies that you might search here and they are not available. So that just means that you can go to Maven directly as we're doing now and then pull that from there. So we can pull that dependency from here and also add it over here. Now we have our Postgres driver and the Spring Starter Data JPA. Right, then we can reload our Maven and we are done with this particular file. We can close our POM file and you can see that now we have resolved all the issues and we can go to our model page. We're going to add a new package here, and this package will be entity, just like that. This entity will connect to our database table that I just showed you now of student. So we'll call this student, and we will add the same annotations that we have in the Pojo. So I'll take these fields actually just like that and go to student, and we'll add all of these fields, and I'll just update that to long, save this. And now the annotations that we need is at entity. Now at entity is an annotation that lets Spring know that this is a database model. So whenever you're interacting with it, please note that it is a database object. So whatever we're about to do, it's either coming from the database or it's going to the database. So one of the two. And we also going to specify the table name, right? Then we're going to say name. The table name in this instance is student, which is what we want to connect to. And then from here on, everything else is the same. So we can essentially reuse all of this. So we're going to have add data, add builder. So I've already explained all of this on the other, on the previous episode. So if you didn't check that out, please do check it out. And then what we want to do here is add some specific annotation. So you can see that my code completer is already suggesting what needs to happen. And I can just click tab, and I already have okay, I'll take the Jakarta ID. I already have the add ID, which notes this field as an identity field. And the generation type of the ID is identity, which means it will auto increment. Right? So now we have our entity here, but we haven't connected anything to this particular database that we're talking about. So what I'm going to do now is right-click, edit connection, and I'll go to the URL, copy this whole URL, and then cancel this, go back to my application, and now I'm going to connect the actual database here. I'm going to go to application YAML, and in here, I want to add a data source. And in the data source, I'll add the driver name, which is the Postgres driver that I want to use, the URL, which is what I just copied now. So I'm going to add that. You can see it's JDBC, PostgreSQL, localhost 5432, and the name of the database. Then username, which is the credentials now. We'll say this is Postgres, and the password, which is password. Right. So this is all we need. We're not doing any liquid-based or database migrations. We just plugging in and interacting with the DB instantly. So that's what we're going to do at this particular point. So we now establish connection to our database. We have our table linked as to which table we'll be talking to. And for any other tables, you'll sort of do the same development or the same implementation. You specify all uh, the entity table and the table name, all the fields that that particular table has. You can see over here, I didn't add the created date. That's because I don't really need that field in here in this particular scope, because I am defaulting that field to the current time, so I don't need to write it explicitly. So I can leave it there and I can edit later. You will see when you start versioning the application how it look like. But let's get into the nitty-gritties of what we want to do. So essentially, coming back here, we now have our database connection established, but our APIs are still not connected to any um, operation that talks to the database. So what we're going to do is add our repository, and that will be a package here called repository, just like that. Right, and then in the repository, I'm going to create a new interface, and I'm going to call this interface iStudent repo. I think that should be fine. And then this particular repository extends. Now this is where JPA and Hibernate come into effect. You will see on the extends JPA repository, and it has an object of student, which is the entity class, and the ID type of long. So you will see that this particular implementation, it expects a type and an ID on the docs over here. And we define that as the student and the long. And now we need to annotate this so that Spring is aware that there is a database repository that we are spinning up, and this should be treated as a Spring Bean that interacts with the database object or handles the transactions that go or come from the database. And that's what that annotation essentially means. Now that we have our repository, we need to add some business logic so that we can be able to talk to all of these database functionalities that are exposed via that repository. So what we'll do is add a new package here, and we will call this service. Then in the service, what we are going to do is create a class, and that class will be, okay, let me make it an interface actually. So I'm gonna call this class, let's call it student, right? Student service actually. Now this is student service, right? Student service is going to have a couple of things, right? So it's gonna find all students from, okay, this will be just a list. Then we also do find student by ID, and we can also do let's say public void, and we will say save or create student actually. Let's do create student. That's what I want to do. Create student, and we will do another one. I actually don't need to explicitly type the public, so I'll remove that. That's fine. So I'll just do student here, and I'll just remove all of these. I'll remove all of these, and this should suffice. So we have a find all, find by ID, create student, update student, and we can do another void of delete student by ID. And then here I want to say find student by ID and find all students, or just find all, that should be fine. Right, so now we have all of these. We need to implement them accordingly. So in here, I'm going to add another package, and this will just be an input package. And in the input package, I will have a student service input just like that. So this class will then implement the student service. So we'll implement student service, and we will then have implement all the methods. Then we click OK. And what we want to do also is to let Spring know that this is a Spring Bean. So we'll say add service, just like that. And we will do some dependency injection here. So we are now integrating this service class into the database transactional handler, which is our student repository. It's actually it's auto-wired, sorry about that. Then we'll just make this private, and we will take in our student repository, and we'll call this student repository. I just want it to be in full, just like that. Right. So now we have our student repository plugged in. What we can then do is, instead of list of, we can just do a student repository dot find all. So now from this repository, if you go back to that interface, you will see there is nothing here. It only extends this JPA repository. So if you go to the JPA repository to see what happens here, there's actually quite a lot that is going on here. So you will see a number of methods of like the find all, get by ID, get reference by ID, delete all in batch, delete all. So there's a lot of implementation going on here, and you can also download the sources to see what's actually happening when we extend that. But under the hood, what it does is it allows us to call such operations and say, in the student repository, which is the database table that is this guy, we want to find all records. So these records here, these two records, we want to find all of them and return them. That's about it. So this is what we'll do. And then Hibernate will go internally, create that SQL statement, write it appropriately before sending it to the DB, and also be able to handle the response to return it back to us in Java list format, and we can send it back. So let's continue to do the other ones, and similarly, it will Hibernate will scaffold the queries for us. So here we are finding by ID, and what we want to do is student repository, and we say dot find by ID. It's already pre-built, so we can just do that. Find by ID dot get, and you see there's some concern there of optional .get without its present check. Right, so we can actually do that, and we say is present, and if you want to be fancy with it, we can just do, I'm going to copy all of this and remove this is present here. So what I'm going to do is add an if statement and say if that is present, then return that. Otherwise, what we will return is return null. Just like that. And you can see we first check if the optional is true, and we return the object. Otherwise, return null. But this is a bad design of calling the repository twice. So what we are going to do is actually assign this to a student object, and that will do a student.find, and that student.find get, we can then say Actually, this needs to be the option. What am I doing now? This needs to be the optional. So optional that, and this will be the optional student, just like that. And we can then say do that. And then in here, we can then check for student is present. And if the student is present, then we return the student.get. And this will be replace optional presence conditional with functional style. Oh, we can do that. And it basically should suffice because now we have a student. If the student is there, give us the student, or else just give us a null object. And now that's in shorter syntax, as you can see there. Going forward, creating a student, what we want to do now is on our student repository, we just send this student to a save. That's it. We save and we're done. Nothing else. Similarly, in an update, you would want to send the student, but this update, actually, I need to fix it on the interface. So what we need here is long ID. Save this. So now we fix this update, and we need to do the same here. Should expect a long of ID. Now the reason for this ID is we want to say student, which is find by ID. We can just call find by ID here, and we pass in the ID, just like so. And then we check if student is not null. What we want to do is student equals to student repository.save, and we pass in the student for let's say this student will say existing student, just like that. And if existing student, just like that, existing student is not now, then we will say our existing student is equals to the repository save student, which is this one here. We'll be saving the student like that and assigning it to the existing student, and then return that particular existing student, just like that. Save this, and now we are good to go. So our update will find the student by ID. If it does exist, update it, and then return it. So how we can even enhance this is just do that one there, and we are basically done just like that. Because if the student does exist, then go and update it and return the object. We are happy with that. And to even enhance this even further, we can actually do a find student by ID even here. Just do that and remove this. So basically now any objects that exist. So we'll have a find by ID, which is if it's not null, save the student and return the object, otherwise return a null. So we've cleaned this up multiple times, but let's proceed with our delete. Right? Similarly, on a delete, what we want to do is call our student repository. Delete by ID is available for us, and you can call that. So it will essentially then scaffold the database query to delete by ID, and it will remove that particular resource. Now that we have all our CRUD operations added as we want, then now we need to plug this into our API controller. So let's go to our controller, and we need to do some dependency injection here. We'll auto wire, and where's this guy? Right, private This will be, I can plug in the student service here, student service. So now Spring will know that, oh, this interface is implemented in one of the beans, which is this guy. Therefore, it will know to execute this code um, once we call our APIs. So our dependency injection is sorted there. What we need now is on this get, we need to fix a few things. So what we'll do is find by ID. We will pass in a ID over here. And then we will then say path variable of long ID. Then we can call our find by ID here, student service dot find student by ID, and we will pass in that particular ID, and we will do a log also here, info, and this will be, let's call this retrieve, just like that, and we will write here find student by ID, and then the ID will be that ID. We're just logging this so that we see how it looks like. So you see the types that we have. This returns a string, so we'll fix it to be a response entity of generic type, just like that. And what we will do here is return a response entity of 200 OK with the student that we got. We're not doing any error checking or try-catch blocks and things like that. Not as yet. We're just writing the code to see what it will look like. We'll add all of that as we go in the series. So now let's see what else we have. So we have our create here, which already has the student DTO. So what we will do is after logging this, we will then have our student service dot create student, but now we need to pass in a student, and what we have is a student DTO. So then we need to use a mapper. So in here on create, I'll actually pass in a student DTO just like that, and save this. Then we'll go to the implementation. Now we'll fix this implementation to take in a student DTO just like that, and we will create a mapper at the very end here, and we can make this private, and this will give us a student. We'll call this student mapper just like that, and it will take in a student DTO, and we will create a new student over here. Now this is where we use our annotations. So we'll say return student, right? And we'll use the builder to build an object, right? And in the builder, we're gonna pass in a few fields. We'll pass in the first name, and we pass in the last name, we pass in the email, student DTO get email, and we pass in the mobile just like that. And we are not passing in the ID because the ID is auto generated, so that should be sorted. And then in here in the create, we will then call in the student mapper just like that. Let me see, what did I do? Oh yeah, that's not right. So then that's sorted. My mapper, and I'll pass in the student, and you'll see now the mapper passes the student DTO. So let's call this, let's rename this quickly to student DTO and student DTO as well here. And then we will save our student after it has been transformed in the mapper. So that should be fine. And similarly to the update, we'll need to do the same thing, but let's resolve this issue quickly. This is in If we control click on here, we will see that this is where we need to plug in the create and pass in the student DTO payload just like that. And because we expect the student to come back, we can actually do, hold on, no, this is void, yeah. So that should be a student. So let me update this to student so that we can see if this was created. Now I need to resolve this across the board. So I'm gonna fix this here as well to be student, and then I'm gonna fix it here as well to expect a student to come back. I'm gonna just say response, and this will be the student, import student. Now we have our student response, and instead of returning the payload, we will return the response, which is the saved student, just like that. So I'm going to save this, and you can see that our create now returns a student instead of being void, and we can do the same for the update. Let's see. Now we're going to the update. We will do the similar implementation. So we'll say student response is equals to student service dot update student, and we'll pass in the payload and we'll pass in the ID. And similarly, the payload is a student DTO, so we need to fix this to be a student DTO in the interface, then resolve this issue in the implementation. Let's go to the implementation. So this will take in student DTO, just like that. And we will also do the same here. We'll use the student mapper, just like that, pass in the student DTO. Let's rename this to DTO and rename this to DTO. Just like that. Right. So now we have a student and the mapper. Because this one here, there is an ID given to us, we can actually then have a different implementation with the ID being provided. And the question here is, when two methods like this are exactly the same and the parameters are different, what do we call that in Java? So there is a specific term for it. Please comment down below and let us know if you have an idea. Right, so now we want to add the ID, and we have the ID like that. And we will do that on the update. We pass in the DTO and we pass in the ID, and we are good to go. So the update is done, the delete is done, and we can check our API. What is it complaining about now? Oh, it's just lost. Okay, so our update is done, and our return on the update should be a response, just like that. Save this. Then our delete, similarly, should be student service, delete student by ID, passing the ID, and we are done. So that is sorted for our APIs, and we have plugged into a database, and everything else Spring will handle for us. We just need to start up the application and put this to the test. So let's run this. So looking at the APIs, let me just close this. Looking at the APIs, we already have a get here by ID. So I'm going to test this one first, get by ID. And we have two records here, 1 and 2. We'll test with those two. So let's jump back to the application and see what is happening. Missing return, where is that missing? Hold on. hold on. Create. Oh, snap. Return that. Okay, missed that one. Let me run that. So if you see, if you look at all the implementation here, there's no checks, error checking, or anything of that nature. We'll add that as we go, right? So the application is coming up, starting, and everything is looking good now. Our application is running on port 8080, just as last time. So we can jump quickly to our Postman, and I wanted to test the get. So we'll do find by ID. I'll call this retrieve, and we will point to localhost 8080. Let's do ID1 body. There is no body that we want to pass, and this should be a method type get, and we send this data. We'll send this request, and we should get our John Doe, and voila, we get a John Doe just like that. And this is the record that we have in the DB, John Doe, blah blah blah. So if we pass ID2 and we send that, we get our Jane Doe coming back, and this is what we essentially expect. Now if we go to our create over here, we can then send through this create without any issues. Let's say John QW and subscriber zip code, and we have all of that. We send this through, and we get a 201 created with ID 3. This tells me that this added in the DB because ID now is 3. If we go to our database, we check the side, let's refresh this, and we have a third record, John QW, and we have our subscriber zip code. And if we go to our update here, and we update John Q, which is ID 3, we have our ID 3, and we will just send this Joe Doe subscribe update to ID 3, which is John QW. Let's send that update. Right, and then we got a response for that ID. And if we go to the DB now, you see the email is subscribe with zip code. The name is John QW. Let's refresh this. Boom. Now 3 is Joe Doe and subscribe update. So all of this has been updated essentially based on what we sent through. And then what we can do is delete. So let's delete ID 3 just like that, and send through this delete. Get a 200 OK. We go to our database, refresh, there's nothing there. Go to our retrieve, which is get, we use ID 3, send, and we get a 200 OK, but there's no response here. So this 200 OK, obviously we'll need to refine it to a 404, but because on our implementation we did not add any other check, so what we can do to fix that 404 is student, just like that, student equals to this find by ID. Let's take that and put it there. Right, and then we will just do a check. If it's null, let's return a 404 not found. Otherwise, return with the student a 200 OK, right? Save that. Let's see if our DevTools is going to refresh. So our DevTools is not refreshing, so we'll just refresh this quickly and see what it looks like. So now when we don't find a student, we should get a 404 not found. And if we do find a student, we should have the data sent back to us as a success. So let's see what this looks like. Cool stuff. The application is started. Now I'm gonna search for the ID3, send this, and it's processing. Now we get a 404 not found, which is actually what we expect. The ID3 doesn't exist. So if you go to ID2, send this through, we should have a 200 OK, and our data is coming back as expected. If we try to find an ID that doesn't exist again, maybe an 8,000 or whatever, let's see, the 404 comes back and we go to ID1, we get a 200 with that particular resource. So I hope this was helpful. Try to keep it short and sweet. And until the next one, for now, cheers.